the last video we have seen about the modern periodic table. In periodic table, these properties, this valency, atomic radius, and ionization energy, electron affinity, electron negativity, and electropositivity, and obviously metallic and non-metallic characteristics, how they will be changed in the periodic table, we have to see now. Okay, right? So first, if you observe this one, already we know that the first one is the S black and the last one is the P black, middle one is the D, and the bottom one is the F black. Already we know that one. Then valency. What do you mean by valency? So the last one is the iron gases. Any atom, in order to get the stability, that will lose the electrons or gain the electrons. What is mean by stability? Except helium, remaining all inert gas having the 8 electron, its valency. That means any atom in its outermost shell, if it contains octet configuration, that means if it contains 8 electrons in its outermost shell, then we treat it as a stable. So then all the elements do like that only, and they will be lost or gained. They will get the nearest inert gas stability by the loss or gain. Suppose if you take this one, hydrogen 1, only one it is there, so its valency is 1. Then lithium, option is 3, 1s2, 2s1. Then 1s2, it will lose and get the helium stability. And it's 4, helium is 2, neon is 10. Which is nearer? Helium is nearer. That means it lost 2, then it will become 2, valency is 2. Then boron 5, it will lose 3, it's 3. Carbon, it is the middle one, either it will be lost, it will be gained, so its valency is 4. Then again coming to nitrogen, its number is 7, it not lost. Why? Because nearest one is 10, so 10 minus 7, 3, its valency is 3. Oxygen like that 2 and fluorine 1. If you observe that one valency is 1, 2, 3, 4 and again decreasing 3, 2, 1, 0. Then this is what lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. I am taking this one. This is the second period. So like this one, if you take the third period, sodium 11 minus 10, helium 2, neon 10, 1, magnesium 12 minus 10, again 2, then aluminum 13 minus 10, 3, silicon is the middle one, and the loss or gain 4, next phosphorus 15, it's 18, it's 15, 3, and sulfur 16, it's 2, chlorine 1, again if you see 1, 2, 3, 4, 4, 3, 2, 1, 0. Then in any period, the valency is gradually increasing up to 4, and after that it will become 0. In periods, valency is increased to 4 and decreased to 0. So then this is about the period. Then coming to groups, this is what 1s1, 2s1, 3s1, 4s1, 5s1, 6s1, 7s1, always having one electron in its outermost orbit. Then valency is same. It is what is the outermost electronic configuration? Valency electronic configuration 2s2, 3s2, 4s2, 5s2. So valency is same. So in group, valency is not same. All elements have the same valency. Then coming to atomic radius. What is meant by atomic radius? The distance between center of the atom to the outermost electron. It is called atomic radius. Suppose it is first orbit, this is the atomic radius. If it has another orbit, then this is the atomic radius. If it has another orbit, then this is the atomic radius. The distance between simple circle radius, atomic radius both are same, like a spherical. So the distance between nucleus of the atom to the outermost electron of the atom, then that is called atomic radius. If you take here, only one orbit is there. Here 1s2, 2s1, 2 orbits are there. Here 3 orbits are there. Here 4 orbits are there. Here 5 orbits are there. So if you observe this one, gradually, whenever you are coming from top to bottom in groups, top to bottom, always we can call top to bottom groups. If you call it a period, left to right, this is right, left to right. Top to bottom in groups, if you go, the atomic radius is gradually increasing. What is one orbit, second orbit, third orbit? Obviously, orbit is increasing, the radius also increasing. So in groups, atomic radius is gradually increasing. But in periods, if you observe the period, this is 1s1, this is 1s2, same orbit. 2s1, 2s2, and 2p1, 2p2, 2p3, 2p4, 2p5, 2p6, same orbit. So if you observe this one, then the atomic radius is decreased. So exactly maximum except valency, remaining all properties, they are opposite to each other like groups and periods. If we learn about groups, no need to learn about period. That is simply opposite. Okay, we have seen the groups, but they will be reverse. So it is increasing, so obviously it is decreasing. That's over. So next, why? Because all are trying in the same period, that means same orbit. Okay. Next, ionization energy. Okay, right. So what's meant by ionization energy? First of all, we have to see these two properties. First, ionization energy and electron affinity. What's meant by ionization energy means, in the name of the ion. So in order to get the stability, some atom they lost the electron, some atom they gain the electron. Electron affinity is another name, electron gain enthalpy. Now you can have some idea about this one. Ionization energy, electron gain enthalpy. Ionization energy, first we have to see. If any atom is there, from its outermost atom, if you want to take off one of the electron, then you require some energy to take off that electron. Then that required energy is called ionization energy. The amount of energy is required to remove an electron from outermost orbit of an atom is known as ionization energy. Why we have to remove that one? To get the stability, it will be lost. Remove is nothing but it is losing. So then losing means you are losing means another atom is try to remove that one. So that's why we can use the word remove. So the amount of energy is used to remove an electron from outermost shell of a neutral atom is known as ionization energy. Then like that only, electron affinity is the opposite one. Their losing is takes place. In some of the one gaining will be takes place. Suppose if you take sodium, it will be lost. It has the ionization energy we have considered. But if you have chlorine is there, the number is 17. It is attracted. So then you can add the electron. Here simple. What happened? So whenever if you give the electron to any other atom, there is a releasing of energy takes place. That means liberation of energy will be takes place. So any electron or the amount of energy is released or liberated whenever if we add the electron to the outermost orbit of any atom is known as electron affinity or electron gain enthalpy. Gain. So in order to gain the electron, it will give some energy to that one, to the other atom. Then that energy released is called electron gain enthalpy. So simply, the amount of energy is released to remove an electron is ionization energy. The amount of energy is released to adding an electron is known as electron affinity or electron gain affinity or gain enthalpy. Then, okay, we have seen the first definition. So this electron negativity. Then this is similar to automatically electron affinity. So electron affinity, electron negativity means name of the negativity. When will we get the negativity? When we get the electron, the nucleus, the charge of the atom should be negative. It will become negative ion, right? So the tendency, whenever if any bonding will be takes place between two atoms, one atom will lose the electron, one atom will gain the electron. Then the atom which is tries to gain the electron, it has some tendency to attract the electron from the other one. Then the tendency is called electronegativity. Then one atom is losing the electron, then the tendency of losing electron is called electropositivity. Whenever electronegativity is there, it will attract the electron, it will become negative ion, anion. Whenever electropositivity is there, it will be lost the electron and it will be getting the positive nature, that is cation. So that is about electronegativity and electropositivity. The tendency of attracting the electron, the tendency of losing the electron. That's it. Then metallic and non-metallic character. Already we know that in the universe metals are there, non-metals are there, and metalloids are there. So as we know that in the 8th class, so little bit I will review that one. Metals have the 5 properties: lustrous, sonority, appearance, and lustrous, sonority, malleability, ductility, and appearance is nothing but lustrous. So and good conductor. Appearance, that means it will be very shininess. That means lustrous. Lustrous or appearance both are same word. Lustrous. So it will be looking very shiny. The object which is looking very shiny. Sonority, which will give the more sound. Malleability, it will make like a spreading into sheets. And ductility, make like a wax. And it's a good conductor of electricity and heat. It should be must possess electricity through it and heat through it. Then if it obeys these 5 properties, then that type of metal is called metal. Otherwise, it is taken as any what is disobeyed, that is called as a non-metal. So this is about the difference between metals and non-metals in the general universe. Then coming to metalloids. So these are the materials which will be having both the properties. They are having the metallic properties and also they are having some of the non-metallic properties. So that means they are having some, not percentage exactly 50-50. They are having both the properties of metals and non-metals. So they are having the middle properties of both the one. Then they are called metalloids. So now coming to here, the nature we have to see. Okay, right? So now ionization energy. This ionization energy. So valence is over, atomic radius is over. So next coming to ionization energy. This ionization energy is gradually decreasing in groups. In groups it is decreasing. Whenever I am talking groups, that is top to bottom. Whenever we are discussing about period, that is left to right, here to here. Okay, right? So in groups from top to bottom, ionization energy is decreasing. Then obviously in periods it is increasing. Then coming to electron affinity. Coming to electron affinity. So then in this electron affinity, this is also same like this one. In groups it is decreasing. In periods it is increasing. Then electron negativity. It is also same. In groups it is decreasing. In periods it is increasing. Then coming to electropositivity. Then obviously it should be difference now, right? Exact opposite. So in groups, electropositivity nature is increases. And periods it is decreases. Then coming to metallic and non-metallic. Metallic nature. In groups, again it is increasing, like positivity. In metals, metallic nature is gradually, as we go from top to bottom, the metallic nature increases. In periods, metallic nature decreases. Coming to non-metallic nature, simply reverse. Metals and non-metals opposite now. So in groups, non-metallic nature is decreases. And in periods, non-metallic nature is increases. Simple logic. If metallic nature decreases means, what it means? Gradually non-metallic nature increases. If metallic nature increases means, gradually non-metallic nature is decreases. Metal nature increase means non-metal decrease. Metal nature decrease means non-metal increase. So simple logic. So this way we have to like this. So then if you read this one, we will get little bit confused, right? To avoid that confusion, among the, how many are there? 1, 2, 3, 4, 5, 6, 7, 8. So valence we take it off. Total is 7. Valence why? Because in groups, depending on the valence only we have to set it. That is one of the factor. So electronic configuration. So in group that is same. In periods 1 to 4 and 4 to 0. So remove this one. So remaining one, if you see this one, 1, 2, 3, 4, 5. Metal is 6. Non-metal 7. Out of 7, if you observe this one, you can remember only groups. Only groups. That too only increasing. I am showing the upward symbol as the increasing. Increasing only you have to symbol. You have to remember. If one period, these are called periodic properties. One periodic property is increasing groups, obviously it will be decreasing periods. Suppose it is decreasing groups, that is increasing in period. Exactly opposite. So out of 7, you can remember only 3 things. What are those being just see here? Atomic radius, electropositivity and metallic nature. These 3 only you have to remember. What I call you? Atomic radius, electropositivity and metallic nature. You can think that positivity, name only the positive, so increasing. Metals, silver, gold, copper, iron, they are most valuable now. Compared to non-metals, metals are most valuable. Suppose later for understanding purpose, for remember, shortcut I am telling like this, not exactly. Like metal, non-metals also more use are there. Okay. Suppose we take silver and gold, we are using like ornaments. These are the more valuable now compared to wood. Wood is a non-metal. So it is increasing order. So positive, name on the positive, increasing, metal increasing, and you can remember atomic radius. The size increases, automatic radius also increases. So these 3 properties are increasing groups. You can remember only this one letter. Atomic radius, positivity and metallic nature. Metals are very valuable. So like silver and gold. And in name of the positive and radius means gradually orbit is increasing. So automatically the radius also increasing. So like that you have to remember, for remember purpose only, these 3 are increasing in groups. You have to remember only groups. Then obviously what happens, these 3 are periods, they are decreasing. Right? Remaining 4 properties in groups, they are decreasing. Remaining 4 properties in groups, they are decreasing. Ionization energy decreasing, electron affinity decreasing, electron negativity decreasing, and non-metal nature also decreasing. If it is decreasing, obviously periods they are increasing. Whenever if you want to write, you can make a small groups and you can write here periods. Then these 3 properties side you can write increasing, increasing, increasing. Obviously in periods what we have write opposite, decreasing, decreasing, decreasing. These 3 are increasing. Remaining left 4 properties are decreasing. That's it. So you have to remember, my choice is to remember only 3 things. What are those? Atomic radius, positivity, that means electropositivity, and metallic nature. These 3 are increasing in what? Groups. So obviously in the period they are decreasing. Remaining properties as usual they are vice versa. These are increasing means these are decreasing. So exact opposite you have to write here. Okay. In groups increasing means in period decreasing. Remaining are decreasing in groups. So in period they are increasing. So this is about the periodic property. I hope you understood. So next we have seen about the metallic and non-metals little bit here. And one more thing, electronegativity. And electronegativity also we can take as a one formula. Somehow ionization energy plus electron affinity by 2. Average of these 2 values we can treat as electronegativity. It will come for 1 mark or 2 marks. Electronegativity, what is the tendency to attract the electrons is known as electronegativity, right? So ionization energy means loss of electron. To remove the electron we have required some energy. To gain the electron some energy is released. This average energy is known as electronegativity. Average means sum of the terms by total number of terms. Electronegativity means average of ionization energy and electron affinity by 2. This is known as electronegativity. Then, so little bit we have to see about the metallic and non-metals. So if you see lithium, sodium, potassium, these are metals, obviously, right? Already I told you alkali metals, alkali earth metals. Next, magnesium, calcium, beryllium, these are also metals. So these 2 are metals. First group and second group are metals. Obviously they are metals. Then what about P? If you observe here, boron, what is the thing is there? Right, see here, this one. Boron, silicon, germanium, arsenic, these are, so see this one, boron, silicon, arsenic and germanium. These are metalloids. They are having both the properties of metals and non-metals. And right side to that one, carbon, nitrogen, oxygen, chlorine, phosphorus, sulfur, chlorine, bromine, iodine, water and maybe, except net gas, no need to add net gas. So that one, the right side of that one are non-metals. Left side of this one all are metal. That's it. You can remember this one only. The total period table. The total period table. Boron, silicon, arsenic, and germanium. These only metallites. So you can make some disorder. If you observe in the textbook, you will give some of the order, discrete order like a staircase. So before this one, left side, all are metals. After this side, all are non-metal. What are these one? These are metallites. So yes, black elements are always metal. Why? Because the metals always have the positive tendency. Always they will give positive nature. So electropositivity is more for this one, metallic nature. So then coming to this one, they are non-metal. Non-metals are obviously electronegative elements. Then what are these ones? These D black elements also metals only. They are lies in between these 2. So that's why the middle. So these are called transition elements or transition metals. Actually, this long transition actors, I told you in the last class, these are also belongs to this 3rd group to 12th group only. So that's why these are also called inner transition elements. So these are alkali metal, alkali earth metals. These D black elements are called, what is that one? Transition metals. And these are, except this circled one is, marked one is metallites. The right side of this part are non-metals. And this bottom, F black elements are called inner transition elements. This is the metallic nature and non-metallic nature. Now coming to next topic, we have to see about the ionization energy very clearly. What is that one? Ionization energy and its effective factor we have to see. Then we have to see about the groups and period. How to find the group number and period number. Now ionization energy and its effective factor. Already just now we seen about ionization energy. What is the ionization energy? Whenever if you want to remove an electron from outermost orbit of an atom, some energy is required. That required energy is called ionization energy. Let me take it into this one. Suppose this is the nucleus. So then coming to this one, this is the first orbit, second orbit, and third orbit, fourth orbit. I am taking up to 4 only, right? So suppose if I want to remove an electron from the fourth orbit, I want to give some energy. It requires some energy. That energy is called ionization energy. So I am removing one electron. So that is called first ionization energy. Then it will become positive ion or negative ion. Right? Obviously it is a positive ion. So then if I want to try to remove one more electron from that one, then again I have to use the energy. Then that energy is called second ionization energy. If I remove one electron from ground state of the atom, then that energy is called first ionization energy. Then again after removing the electron, it will become unique positive ion. That means it will become plus. So then if I want to remove one more thing, then it will become di-positive ion. Then the energy, the required energy is called ionization energy 2. Then once think that which is more energy, first energy or second energy, which energy is required more? Right, obviously the second is more. Why? Because every atom, suppose you only there, some little bit example is there. If you have something with you, some food item is there, I am applying some force and I have to take that food item from you. Suppose you have some 10 chocolates with you, I have to apply some force and remove that one chocolate. You are easily given. Why? Because you have 9 with you. Each is come. Then you are easily given the one chocolate. Then that energy is required. Suppose if I want to add one more thing, then you are easy to accept to give that one. You are refused more and more. Right? You are applying your force also. You are in order to not give that one. But again, if I want to get that one, obviously, then I have to apply the force which is more than the previous one. So like that only, atom is a little bit ready to give the one electron to get the stability. Still, if you want to get the stability, still if you take off the one more electron, then it will be tries to avoid you and it will also not given to you. Then you have to give the more and more energy for that one. Then obviously the second ionization energy is more. Why? Because it is a unique positive ion. First it is in ground state, so we can easily remove that. But now it is ion position, then it has required more energy. So like that, if you want to remove, then that is IE3. That means ionization energy 3. There is a more energy. So that's why the first ionization energy is less than the second. Second is less than the third. Third is less than the fourth. Like that, so on. Why? Because in first state it is in the ground state, so we can easily remove the electron. In the second state, after removing the electron, it will become unique positive ion. Then it is hard to remove the electron easily. So we have to apply the more and more energy. So that's why the second ionization energy is more. Then these are the factors affecting the ionization energy. How it will be affected. These are the 5 factors we have to discuss now. Nuclear charge, screening effect, or one more name is shielding effect, penetration power, then stable configuration, then atomic radius. So if you see the nuclear charge, what is meant by nuclear charge? The attraction of the nuclear charge. Nuclear charge is nothing but if the charge is more, then it has a more attraction power. If the charge is less, it has a less attraction power. Already you know that one, K, L, M, N, like that is there. Both models are suppose some what is that orbits are there. This is the nucleus. On which orbit the attraction power of the nucleus is more? First orbit or last orbit? First orbit or last orbit? Obviously, for the first orbit, the attraction of the nucleus is very much high than the last orbit. Then it is easy to remove electron from last orbit is easy or first orbit is easy. From where we have to easy to remove? Right, obviously we have to remove from the last orbit. Why? Because the electron charge, the electron attraction power on the last orbit is less, so we can easily remove. On the first orbit, the electron attraction power is more, so you can't remove easily. So here the ionization energy required is more. Here the ionization energy is required less. So simply you can write in 2 lines. If nuclear charge is increased, we have to increase the ionization energy. If nuclear charge is less, the ionization energy also less. Right? Nuclear charge is less, attraction power is less, you have to apply the less energy. Nuclear charge is more, attraction is more, then you have to apply the more energy. Then screening effect. Suppose I want to remove electron from here. Okay, 4 orbits are there, some of the electrons are there. So I will explain you. So all just now we seen about this one. Which is easy to remove? First orbit, second, third, fourth. Which electron removing is easy for us? Fourth orbit removing electron is easy. Then third, then after 2, then 1 is very impossible. So then like the screening and shielding here. Why like this means? So if you want to remove the electron from the first orbit, you are here. That means you means other atom is here. Then you want to try to remove electron from the first orbit. Then what happened? This second orbit, third orbit, fourth orbit, they are present in the middle of you. Then automatically they are acting like a screens. They are not acting like a shields in between the outer atom and the original atom. So from the other atom, it is try to remove that one. But the second orbit, third orbit, this fourth orbit, they are acting as a curtains. So they are acting like a shields and screens. So then it is easy, it is hard to remove. So this effect is called screening effect. This effect is called screening effect. As the screens are more, that means as the orbits are more, then we cannot easily remove the electron from the innermost orbit. We can easily remove the electron from the outermost orbit. First thing is nuclear charge is more on the innermost, and second thing is this one, the energy is discharged by traveling through this orbits only. Then these are act as screens. So this is also called as a shield, right? So next, coming to penetration power. So suppose fourth orbit is there. Fourth orbit, how many are there? Orbitals? Yes. How many orbitals are there here in fourth orbit? S orbital is there, P orbital is there, D is there, F is there. In fourth orbit, S orbital, P orbital, 4s, 4p, 4d, 4f. Okay, we are giving electron. So after completing the third orbit, the electron settles into which orbital? S or P or D or F? 4s, 4p, 4d, 4f. Obviously 4s, 4p, 4d, 4f. In which one it is entered? It is entered into S. After filling the S, it is entered into P. According to what is that one? Energy level. Already we seen in the Auger principle and what is that one? Hund's root. They will be filled. According to Auger principle, that will be filled. So S, P, D, F. Then filled S, then enter into P, then enter into D, then enter into F. This is already we know the order. Then from which we have to remove the I have to remove the electron easily. As S or P or D or F. Right. Obviously we can easily remove the electron from F orbital, not S. Why? Because you can think that like a order S, P, D, F. Electrons directly enter like orbits. Orbitals also in order. Suppose if you think that one, simple as na. S, P, D, F means S means L is equal 0 orbital. P means L is equal to 1. It is little bit later. L is equal to 2. L is equal to 3. According to both Sommerfeld model. So that will be what is that one? Elliptical path. So it will be distant. So S is fast, next P, next D, next F is there. Then electron enters into here. You try to remove this one. On the S, compared to S and F, all are similar only, matter. So compared to S and F, on which one the nuclear attraction is more? On S it is more. So you can't remove easily. But on F it is less. So you can easily remove out. All are depending upon the nuclear charge only. So this is called penetration power. The electrons is penetrating through F, D, P and S. Penetration means it is entering into so far distance. So that means F, it is not entering into F easily. First it is entering into, it is passed through F, find D and P, finally settled in S. After filling this one, enter into P. After filling in D, after F. So this penetration is there. So automatically we can't easily remove the electron from S orbital. We can easily remove the electron from F orbital. Why? Because the penetration power of S orbital is more than the F. The electron is easily penetrated and entering into S, and finally it is entering into F. So we can't remove this one. Still here also we can take the nuclear charge concept only. Then simple logic, penetration of S orbital is more. So nuclear charge is more. So we can't remove. So we can require the more ionization energy. On F penetration power is less. So it is attraction power of the nucleus on the F is less. So we can give the less ionization energy. Then stable configuration. Why we have to remove? Actually, ionization energy means we in order to remove, we have to give some energy, right? why we have to remove the electron? Why we have to require? To get the stability, na? Suppose sodium is there, 11 electrons are there. It wants to lose one electron, you are trying to remove that one, it is easily given to you. Then it will become 10. Now it is near configuration. It is stable. Still if you want to remove that one, it is capable to giving you. It is possible to give you. Not. Why? Because it is already stable. How can it give to you? So it is still it will give, but if you apply the more and more and more energy. So that's why if any atom is get stability, then we can't remove easily. Is it clear? Suppose for example oxygen and nitrogen if you take. Oxygen number is 8. Then we can remove 2 electrons from that one. But nitrogen number is 3. So nitrogen number is 7. Nitrogen number 7, oxygen number 8. Suppose, how can I show you? Okay, right. I will draw the electronic configuration. Oxygen 1s2, 2s2, 2p4. That is about oxygen. 1s2, 2s2, 2p4. If you want to remove one thing, then it will become 2p3. If you want to remove one thing, it will become 2p3. Then after 2p3, what will happen? It's all off filled. It's all off filled. Now it's 2p4, you are doing this one. Okay, it is given. Now it is 2p3, it is off filled. Then it is more stable than the previous one. It won't give. This 2p3 configuration is for which one? For nitrogen. Nitrogen is already off stable. So we are required more energy to remove this electron. Are you clear? So if the stable configuration is there, whenever any atom is stable or any stable, you don't want to get bonding. So that's why we have to require the more energy, more ionization energy. More stable, more energy. Then coming to atomic radius, is as usual this one only. If atomic radius is already, just now we seen about this one. This is the atomic radius. If any atom, if one atom is there, this is the atomic radius. The distance between center of the nucleus of the atom to the outermost electron. If only one atom, one electron, one orbit is there, this is the atomic radius. 2, radius is increased. 3, radius is increased. 4, radius is increased. So like that, if the radius is increased, then automatic attraction power of the nucleus on the outermost orbit is decreasing. If the radius is this much is there, on the outermost orbit, and the radius is increasing. Observe 1, 2, 3, 4. 4 cases if you observe. 1 orbit atom, 2 orbit atom, 3 orbit atom, 4 orbit atom. In this one, from which one we have to easily remove? For 4th orbit. Why? Because for 4th orbit the attraction power is less. The nuclear attraction power is less, then we can easily remove. As is this one only. This one line, if you add it to this one, you can easily write. What is that one? If atomic radius is increased, then nuclear charge is decreased. Then we can easily remove ionization energy decreased. If atomic radius is decreased, then nuclear charge is increased on the outermost shell. Then we can't easily remove that electron. So we have to apply the more ionization energy. So this is about the ionization energy. So this ionization energy is, we can measure it in the kilojoules per mole or electron volt per mole. Why? Because already energy is we measured in joules. So this is with respect to ions or atoms. So that's why we can measure the mole. This is measured in the kilojoules per mole or electron per mole. So like this we have to measure the energy of the ionization energy. So these are the affecting factors. And a last topic in this lesson is there to find the group number and period number of a given element in direct manner and in shortcuts. How you can find? So first, for getting this one, we have to see this one. So electronic configuration of these 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10 up to 30 I am writing. 2, 4, 10, 12, 18, 20 and 30. Okay, right? So then coming to this one, if you see here 1s2, 2s2, 2p6 is totally 30. So what is our target is to find the group number and the periodic number of any element in the periodic table. So the original method I will show you, and after that I will tell the shortcut also. Choose any this one. Suppose for example phosphorus. Shall I take the phosphorus? So then phosphorus number is how much? What is the phosphorus number? Phosphorus, it is about 15, right? So the phosphorus number is 15. So then coming to, that is the aluminum 13, silicon 14, phosphorus 15. Then write the electronic combination 1s2, 2s2, 2p6, 3s2, 2, 4, 10, 12 and 3. 2, 4, 10, 12, 3, 15, right? So now in this one, this is the first write the electronic configuration. Then Take this is the electronic configuration. Then write the valency electronic configuration. What do you mean by valency electronic configuration? Outermost orbit configuration you have to write. In this one, how many orbits are there? 1 means first orbit, 2 means second orbit, 3 means third orbit. So you have to take the valency. So up to this near over. So then this is about the valency. Valency is nothing but outermost orbit configuration. In other words, after completion of the direction and gas configuration, remaining is the valency. Up to 10 neon is over. So then 3s2 3p3. So see there, the prior number n value is there. This n value is called 3. Here how much we are taking n value 3. So what do you think that this is the third orbit? This 3 will give you the period. The number which is before the orbitals are there, that will give the orbit number, third orbit. Third orbit nothing but third period. Periods are nothing but orbit. See, observe this one. If first orbit is finished, helium 1, 2. In second orbit, according to both, first orbit 2, second orbit 8, third orbit 18, like that electrons are there. First orbit 2, 1 and 2, it's finished first period. Second orbit 8, 1, 2, 3, 4, 5, 6, 7, 8, over. Then 18, 1, 2, then after that 8. So then, according to other rules are there, opposite and rules are there to obey this one. So if you see there, if that orbit is fixed, then we can take as a period. So valency if you take 3s2 3p3 is there, valency. You can take only valency. Then 3, 3, this is the period 3. Period number. Then group. Then simply add the valency number of electrons. Valency orbit will give you period number. Valency number of electrons will give you group number. How many electrons are presented in the valency orbit? That is group. What is that the valency orbit is known as period. So this 3 is called period. Then group. 2 plus 3, how much? 5. Let's check. Fifth group and third period. See the third period. Fifth group. Where the fifth group is there? Here. Suppose the third group, fifth is here, not presented, right? Now going to here. Fifth. See there. Third period and fifth group. So this is the fifth. 15 means fifth. Over? Alright. Try to take the other one like this only. Another one. Let's take any one. So then which we have to take? Okay, calcium if you take. Calcium is nothing but 20. See here, 1s2, 2s2, 2p6, 3s2, 3p6. Up to here, 18 is over. Then what is the calcium? 4s2. Valency. What I told you, to write the valency electronic configuration. Total valency, only 4s2. 18 plus 2, 20. This is only valency. Then, the before one is gives you the period number. Period is how much? 4. How many electrons are there in this one? 2. So the group number is 2. Fourth period and second group. 1, 2, 3, 4. Fourth period and second group. It's so. Right? So like this, you can write first. Okay, you can take the middle one anything. Suppose if you take the copper. Copper number is obviously 29. Then up to here we can take 4s2 3d9. I think 3d10 is zinc. 4s2 3d9. 4s2 3d9 here there. Up to here what is there? Argon is there. 2, 4, 10, 12, 18. Argon. And 4s2 3d10. 2, 4, 10, 12, 18, 20, 30, right? 29, 4s2 3d9. Now I have the fourth orbit is the third orbit. Which is the valency we have taken? What I told you, in valency how many electrons are there, that much you have to take. I told you like that. That means after inert gas configuration you can write that is totally valency now. Inert gas configuration, after inert gas, which is the valency, then you can write that one. Here what is the after inert gas? Up to this is the inert gas. 1s2, 2s2, 2p6, 3s2, 3p6. This is the 18 argon. So up to argon you have to cancel this one. The remaining is called valency. Then I have doubt here. Okay, we will clear. Group number is what? In valence how many electrons are there? That is group number. 2 plus 9, 11. It's okay. 11 it is got. You got. But what about the period? Here I have 3 number is there, I have 4 number. Which number I have to take? Always you have to take the larger number. Why? Because valency now. Valency means outermost shell. Compared to 3 and 4, which is the outermost? 4 is the outermost. You can take 4. Let's check 4th period and 11th group. This is the 4th period, 11th group. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Have you got it? 11th period. 11th group. That's it. So like this you have to get this one. So already we know that 11th is nothing but what now? 1B. Already we know that 13 means 3A, 14 means 4A. Like that if you remember, you can write like this also. So this is about the original method of finding groups and periods. So now we have to see the shortcut. But in the examination, if you ask for half mark or 1 mark, it is a waste of time to remember to do this one. Okay, it's the original method, you have to remember compulsory. But at very shortcut I will tell you, just listen. First you have to know the numbers of inert gases. What is the first number? 2, helium. Next 10, neon. 18, argon. 36, krypton. Enough. Why? Because we have up to 31, imagine up to 30 cases we lost. Okay, right. 2, 10, then 18 argon, krypton 36, next xenon 54, like that you can take. Okay, water will 50, 54 also you can take. What is this one? Xenon. Right? So this is our xenon. Okay, no. So up to 36 only it will be required for us. Right, water will take. Okay, right? See here. Tell me any number, any atomic number. Any atomic number, just so up now we are saying like this now. So that is the original method, the shortcut. Suppose, for example, if you take the number 17. 17 we know that it's chlorine. First, write 17 middle. Before 17 inert gas number, after 17 inert gas number you have to write. 17 is there. See this, you have to remember only these numbers, it's enough. Actually this 4 numbers is enough. Now see there, in which numbers between this should be presented, this 17 is presented, see there. 2, 10, 8, 2 and 10 not possible, 10 and 18 is possible. So it is lies between 10 and 18. Right, like that one. In which number is like 10 and 18 like that. So after number we don't require, just leave it. Then you have already know the subtraction. So do this 17 minus 10. 17 minus 10 how much? 7. 17 minus 10 is the 7. So it will give you group number. Simply group number. Okay sir, period is gone. Period is already came. So then what about the, it's clear about group. Already group is came, it's clear. Then what about the period? So then simply think that if 2 is there, if the period number is 2, that is first period. See the first period 2. Second period 10. Third period argon 18. Fourth period is krypton 36. And fifth period is obviously xenon 54. So the number 10 is which one? 2. So it is the second period. But at 10 it is finished. After 10 your 17th is there. That means it is ended in which period? Third period. So period is 3. Now check it. Third period 7th group. Third period 7th group. 1, 2, 3, 4, 5, 6, 7. Chlorine is 7. Is it clear? So like that. Simple logic. First write the number. Right in between what between it is there. You have to write. So next subtract that one. The answer will give you group number and period number is. Before number, which number you are subtract you have to see. Suppose that is the second period. Then you can write as a third. Suppose the third period you can write as a fourth. Why? Because up to 10 it is over. After 10 only present. So like this. Suppose for example, give me one more number. Some 24 for example. What is 24? Obviously chromium. We know that. So like this one you can write 24. Line between where? 18 and 36. 18 and 36. So no need of this one. Subtract this. 24 minus 18 how much? 6. So it's a group number. It's a group number. Next, then what about the period? 18. 18 means 1, 2, 3. Third period over. After third period it is presented. That means next row. It's a period is 4. Next check. Fourth period 6th group. This is the fourth period 6th group. 1, 2, 3, 4, 5, 6. Have you got it? 6th group. So see here 6th one. That's it. So like that. Either original method is you have to write the electronic configuration. You have to remove the up to inert gas configuration. Then valency is gives you valence element will give you the period and number of electrons present in the valence shell or give you the group number. So that is the original way. If you want to shortcut, you have to remember this number. You have to write the given atomic number and you have to write these two numbers. Then latter number is not required. Before number you have to subtract. The subtracting answer will give you the group value. And coming to period, this number will give you some period. After that only your number is there. So that's why next number you have to take as a period. So group and period like this. Subtraction number gives you group and remember starting number will give you before period. And if you add the next one, so that is the after period. Why? Because 18 is ended for 2. Then 19, 20, 21 up to 35, that is fourth period. Simple logic. From 3 to 9, 3 to 10, 1 to 2 first group, 3 to 10 second period, period. 1 to 2 is first period, 3 to 10 second period, 11 to 18, and 19 to 35 fourth period. 19 to 35 fourth. 24 is there present. 19 to 35, that is fourth. That is fourth. So like this you can remember. Anyway you can choose either shortcut or general method. But suggestion is you have to remember both the things. Whenever the shortcut is not wrong, if you forget it, it is helpful for the first one. So thank you very much. So this is about the total periodic table. So in this topic we are discussing about the what is that periodic properties and the ionization energy and affecting factors and how to find the group number and period number of a given element. And this is about the total part of the periodic table and metallic nature, non-metallic, all we have discussed. So you have to go through these three parts, part 1, part 2, part 3, then you can learn more about the periodic table. Still if you have any doubt, you can message me in the contact box, that means in the chat box. So thank you very much. Please subscribe our channel and refer to your friends. Thank you very much.